When they give you 0 in a number, they are giving your initial condition. Because if you were to put 0 into the exponent, what is anything to the 0 power? 1. So you just end up with a equals that y. So if they give you 0, they are telling you what your a is. It's like when they give you 0 and a number and you're graphing with slope-intercept. They gave you your y-intercept. That's what they did, which is what your initial condition is on a graph. It's your y-intercept. So when they give you 0 and a number, they've given you your y-intercept for a line, and they've given you your initial condition for an exponential function. So if you remember that it is in the form y equals a b to the x, and a is your initial condition, then you already know what a is. So we already know that we're going to have y equals 24, a to the x. Just figuring out what a is. And so then we're going to use our x and y that they gave us. Had they not given us that 0, then we would have done what we did on that example where we had to solve back into one of them and then solve back into the other. But they gave us one. So now we just have to solve for b. I wrote a. I meant b. There we go. So we're going to plug in our x and our y and solve for b. Our x is 8/9. No. Our y is 8/9. All right. Equals 24, b to the x. All right, b to the x. Then we're just going to solve. How do I solve?
You divide by 24.
Yeah, I divide by 24. Right? Okay. All right, I have 8/9 divided by 24. What do I do with that guy?
Keep, change, flip.
Yeah, keep, change, flip.
I learned that on the last test, guys.
Keep, change, flip. That's correct. So if you want to do keep, change, flip, yeah, it goes keep, change, flip. Right. Can I reduce that in any way, shape, or form? I can. How can I reduce it?
By 4.
Right, by 4. What do I get?
2 9s and 1 6.
And so I can reduce it again. So
Yeah, you can take out the 8.
there we go, 8.
I was like, girl. No, you can do that too.
All right, so you end up with, I did it backwards again, 1 and 3, right? So we have 1 over 27 equals b cubed. How do I solve for b? Cubed root of b, which hopefully y'all know that, right? Cubed root of 1 is just 1. Cubed root of 27 is 3. So then I plug it back in, which is what gives me this little guy up here. Y equals 24 1/3 to the x. So when I look at this particular graph, I'm looking at where it starts. It's starting right here. So I already know my a. That's how I already know this guy right here is that it's given to me at the very beginning. So I'm going to say y equals a, b to the x. And then I just need to pick an x and y. I would pick one that is as close to, like I would probably use this and use 4 and 8,000 personally. So I would say 8,000 equals 12,000 b to the, and you know what? Actually, I'm going to use squared because I don't want to take the fourth root. So let's do squared. Change my mind. I'm going to do this one. 2 and what, 10,000? So we'll say 10,000 is my y equals 12,000, which is my x, which is my a, b to the, and we're going to say 2 there. You could do the other one, but then you have to do fourth root. I don't feel like doing that. All right. My first step here is to do what? Divide. All of these guys cancel here. I can reduce him, right, by 2. This does not have a perfect root, so they had to have rounded that, right? And they got 0.9. And then did they want you to evaluate for 6? So then you just go back and plug a 6 in for that guy. So here's your function you should have gotten. To get this, plug a 6 in there. This is just, this is your principal amount. This is your interest rate, 0.076. This is your time, 1.5. Plug it in. Logarithmic functions as inverses. So this whole time in this chapter so far, we have been doing exponential functions. That's this guy right here, y equals b to the x. Remember, if your variable is in the exponential place, that is an exponential function. A logarithm is simply the inverse of an exponential function. Well, what do we mean by inverse? We just talked about inverses. Inverses cancel each other out. When you do an inverse of itself, when you do a composite, you should get x. We've dealt with inverses since we started doing equations. If I were to say, hey, this is x plus 3 equals 7, it's plus 3, so what do? You subtract it, because subtraction is the inverse of addition, right? And it cancels it out. That's what it does. So inverses cancel each other out. If you multiply by 3 and then divide by 3, you're back where you started from, right? And so that's what we found when we did inverses in the last chapter. If you do the inverse and then do the inverse of the inverse, then you're back where you started from at x. All right, and it's the same thing with logarithms. If you do an exponential function and you do a logarithmic function, they cancel each other out because they are inverses. And so the real key is figuring out how to rewrite them. And then once you understand how to rewrite them, then you can take a log and you can rewrite it as an exponent, or you can take an exponential function and rewrite it as a logarithm. And they talk back and forth to each other because they are inverses. Just like you could rewrite addition and subtraction. Subtraction is adding the opposite. You can rewrite it as the inverse of itself, because that's what inverses do. So if we have this function y equals b to the x, what does that mean as a logarithm? Well, the y here is really telling me what I find when I take some number to a power, right? For example, if I have 9, that would equal 3 to the second. Yes? So the y in this particular function is my answer in an exponential function. What is that number when I take another number to a power? When I am doing a logarithm, that is the number I'm looking at to begin with. I'm saying, what do I take this number to the power of to get this guy? Your bases are the same. My base here and my base of my logarithm are the same. Here, my base is 3. And so my base of my exponent becomes the base of my logarithm. And now my answer of my logarithm is my exponent of my other function. So how would I rewrite this guy? Well, I would say if I want to rewrite this guy as a logarithm, then I would say my log base 3 of 9 equals what? It equals 2. So what am I asking when I look at a logarithmic function? I am asking this particular base has to be taken to what power to get this number? That's what a logarithm is asking. So if I just gave you this question like this, you would say, what power do I have to take 3 to get 9? And your answer would be 2. And that's what a logarithmic function is. You have a base. The base tells you what number you are taking to a power. Of what tells you what number you're trying to eventually get. And your answer for a logarithm is the exponent that you would take it to. They are inverses of each other. Now, this is a really easy example. And you're going to get questions that just test your knowledge of, hey, do you know how to rewrite it? So what would the exponent be? Don't use a calculator. But then there are other times when you're given something like this. And I would say log base 3 of 23. What power do you have to take 3 to get 23? Well, it's definitely not a whole number, right? And so this is where if you were to do logarithm in your calculator, you're going to get these crazy decimals. Well, the reason you're getting crazy decimals is it is telling you what your power you're taking that 3 to get to 23. It's not a whole number. It's going to be a decimal. Now, in your calculators, you have 2 logarithmic functions. One looks like this and one looks like this. Okay? Your base of this guy is a 10. So when you see the word log with no base, you have an assumption. Just like when you see a radical with no index, you have an assumption. Just like when you see a variable with no exponent, you have an assumption. Your assumption for this log with no base is base 10. That's what our bases are for our numeric systems when we do exponents. Think of it as scientific notation, right? It's going to be the inverse of your scientific notation, 10 to a power. Okay? So if you have log, that is going to be base 10, unless it specifically gives you another base. ln is base e, which is what we just talked about when we did PERT. 2.17, blah, 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 goes on forever, right? So log is base 10, ln is base e. And so if you were to do those, you would say, for log, well, what power do I have to take 10 to get this number? So in your calculators, if you put in 100, log of 100, you should get 2, right? Because log base 10 of 100, what power do I have to take 10 to get 100? 2. So in your calculators, if you just do log of 100, you should get 2, because that's what power you have to take 10 to get to 100, okay? So that's all logarithms are actually asking for, is what power do you take your base to get this number? Whereas exponential functions say, hey, take this number to a power and tell me what the number is. So it's just inverses. Let's look at rewriting them. So the first thing I want you to just know how to do is how to go back and forth between logarithms and exponential functions. So look at this first example. Write 25 equals 5 squared in logarithmic form. So I'm going to say log. What is the base here of my exponent? 5. So the base of my log is 5. What is my answer? 5 is 25, right? And what power do I have to take 5 to? That is 2. That's how I would rewrite that in logarithmic form. All right? My base of my exponent is the base of my logarithm. The answer of my exponent is what I'm evaluating for my logarithm. And the exponent of my function is the answer of my logarithm. All right, so rewrite those 3. Really straightforward, right? I mean, log base 3, blah, blah, whatever. This guy right here, a fraction can be in your base, okay? It's fine. It will likely be a fraction when you take it to a power, right? Because, you know, you're taking a fraction to a power. I do want to point out this 10 to the 0. Anything to the 0 power is 1. So the log of any base of 1 is going to be 0. Like if you put any base in here, it will be 0. Because you're saying, what do I take this number to get 1? And it's going to be 0, right? And so this is something you're going to see as you do some solving of equations that you just want to be aware of. Evaluate log base 8 of 16. So this does not look intuitive as the base 3 of 9, right? Because obviously we can see. When you're looking at this, you're like, well, 8 can't take to any power and get to 16. So what we do is we actually rewrite it, right? And so I am going to rewrite this guy in exponential form. So when I do that, I'm going to make this equal to x, just so that I can figure out where my variable is going to go. So I'm going to rewrite this now from logarithmic to exponential form, okay? So I'm going to say 8 to the x, right? That's my base, and x is my exponent, equals 16. What I notice about these two is they have a common base. By that, I mean I can take something to a power, the same number to a power, and get to these two numbers. What number can I take to a power and get to 8? And I can take that same number to another power and get to 16. 2, yeah. So I'm going to rewrite the 8 as 2 cubed. So that's 8 to the x, right? And I'm going to rewrite the 16 as 2 to the 4th. Everybody see that? Now, exponential properties that we just talked about yesterday, right? Power to a power. Well, how do I rewrite that guy? 2 to the what?
3x.
2 to the 3x equals 2 to the 4. Now, here's the deal. When you have the same bases, you can assume that the exponents equal each other as well. Why is that true? Well, 3 squared equals 3 to some power. Well, it has to be 2. That's the only thing that's going to work there, right? And so when I have this, I can now solve for the variable that I'm looking for by just setting my exponents equal to each other. What do?
You divide.
Yeah, I'm going to divide x equals 4/3. Now let's see if that works. So my answer here is 4/3. Does 8 to the 4/3 equal 16? Well, what does this mean? This means the cubed root of 8 to the 4th power. What's the cubed root of 8? 2. What's 2 to the 4th power? 16, and boom, we're done. So one way to do this is to rewrite them in like bases so that you have the same base to powers, and then you can set the powers equal to each other and solve. So sometimes it'll be intuitive. Log base 3 of 9 is obviously 2. 3 squared is 9. But sometimes it's not intuitive and you're not going to immediately see it and you have to rewrite it. So go ahead and try those 3. I already talked about this, but we're gonna define it. The term common logarithm is base 10. So on your calculator, when you see just this guy, this is called a common logarithm. So if you hear that term, they're talking about log base 10. Okay, log base 10. This is just showing you the functions. When you graph them and their inverses, they reflect over y equals x. So y equals x is this guy right here. The little one slope going through your 0, right? That's your y equals x. Inverses will always reflect over that. So if this is my exponential function right here, this is my logarithmic function right here. So they're just showing you that. Common log, and then we're about to do log base e in the next sections, all right? So when you have properties of logarithms, what this actually does is you can break up the logarithm into multiple logarithms, or you can be given multiple logarithms and condense them into one. The key here is, one, they all have to have the same base, or when you break them up, make sure you keep all the same base or you haven't expanded correctly. If you have a logarithm with a group inside of it, so I'm taking the log of some group, you could look at the properties that are going on within that group, and sometimes you will be able to then change that group based on what's going on the inside of it. The first property that we're going to talk about is our product property. All right, so for this product property, you have a logarithm, and inside your logarithm, you have two things multiplied together. You can expand that to be two logarithms. You can say, well, the logarithm of these two things multiplied is the same thing as if I take the logarithm of the first one and add it to the logarithm of the second one. So for products, you can expand with addition. So if it starts out as a product, the logarithm of a product, you can change that to be two different logarithms added together. All right? The second one is division. For division, I have a logarithm of some division, two things divided. I can break that up into two different logarithms, the logarithm of the top numerator and the logarithm of the bottom, and that changes to subtraction. All right? And then there will be times when you have a logarithm of something taken to a power. A logarithm of something taken to a power. You can take that and say, well, it is the same thing as the logarithm of that number multiplied by the power. And the power actually goes in front to be multiplied. All right, so we're going to do some of these so that you can see it in action as we are expanding these. So let's look at this first one here. We have one that's already expanded on the left and one that is condensed on the right. And they're showing us to state the properties, what they used. So let's look at this first one. They just want us to name the properties. They don't want us to actually expand. We're gonna simplify in just a minute. All right. What did they do? Well, they started out with a subtraction, right? So we have a subtraction of 2 logarithms, and we ended up with 1 logarithm. Well, let's see what happens when we condense this guy. It's the same base, so I know I can apply these properties. So I can change this and say this is log base 2. My property for the quotient, right, division, my quotient property, says that subtraction can go to quotients and quotients can go to subtraction. It works both ways. This is my numerator. The one behind the subtraction is my denominator. So they use the quotient property here. Because they're telling me that that equals this, which is true. They're using the quotient property. Let's look at this next one. We are going to expand it together and see what they did. Anytime you have multiple things going on, I try to start with the easiest. In this case, you have just the x to the power here, just the x to the power. So I'm going to look at what's going on in between these two right now. So what's going on in between the x cubed and the y? What? Multiplication. I have a product property that says I can split these into 2 logarithms. I have to keep the same base, but it's going to be the logarithm of the first one plus the logarithm of the second one. That's my product property. I can separate them by addition. I have one more property that I can rule. So this one is the product. They use product first. I also have an exponent, power property. My power property tells me I can take this exponent and put it in front. So I'm going to rewrite that one as 3 log b of x plus log b of y. And that's how they got their answer. Power property. They're just using the properties to rewrite it. They're just rewriting it. We're not solving anything, we're just rewriting them. Either they're rewriting them from expanded form down to 1, or they're rewriting them from 1 to expanded form. It can happen both ways. Both ways. All right. All right, write each logarithm as a single logarithm. So this is what's called condensing a logarithm. You're going to use this when you solve equations. They want us to take these and rewrite them as 1. The first thing you have to check is that possible? Do I have the same bases? Log base 3, log base 3. Yes, I do. All right. So then I'm going to say, what's going on in between my logs? Well, I have subtraction going on. So I'm going to use the quotient property to condense this. All right. So I'm going to say log base 3. What's my numerator of my quotient? 20. What's my denominator? 4. And I can actually, because it's all numbers, if this were variables, I would be done. But these are numbers, so I can actually simplify that one more step. How can I rewrite 20 over 4? There we go, and that's my answer. All right, don't forget your base. That will be points off. I need a base 3 there, okay? Let's look at the next one. This is going to be multi-step. When I have something like this, and I have that coefficient, I'm always going to start with that. So my power property tells me I can take this 3 and it can become the power of this guy. So I'm going to do that step first. Log base 2 of x cubed plus log base 2 of y. That's my power property. My exponents can become my powers. If I'm expanding, powers can become exponents. All right, or coefficients. All right. I have one more property I can use. What's happening in between those two logs? I'm adding. So what can I change that to? 1 log with multiplication. Log base 2 of x cubed y.
Do you need the parentheses?
For clarification, I would probably put that there. So I look at this, they want me to expand. So the other way they gave me multiple logarithms, they want me to condense. There they're giving me 1, they want me to expand. All right, so I'm dividing here. What's my property tell me I can do? You're dividing them, what can you break it out with? Subtraction. It's gonna always be the same base 5 of my numerator, minus the same base, my denominator. And if you have to remember your exponents, what do you do with the exponents? Subtract. All right, let's look at this next one. I'm expanding. I'm going to start with the exponent, and I'm going to multiply by it. So I'm going to say 4 log of 3 times, oh, no, I'm not going to do it because that's not grouped. And this is why I pay attention to this. This is only, the r is the only thing to the power. This is why parentheses matter. The r is the only thing to the power, so I'm actually going to expand here. Had that group been to the power, I would have done that. So I'm going to expand with the multiplication first. Expansion with multiplication tells me I can do what? Yeah, log base 10, so you don't have to write it, of 3 log of r to the 4th. And now I'm going to do this because that was only on the r. So log of 3 plus 4 log of r. And I can't expand anymore, I'm done.
Would you just put in the
Right? You can have something that looks like this. How would I rewrite that as a power? What is the square root of 5 rewritten in exponential form? 5 to what power?
The -2, right?
I don't know. Square root's written 5 to the 1/2.
Oh, because it's the inverse of
So when you see the log of a square root, it's actually a power that you can put in front. And so if I were to expand this one, I would say, well, 1/2 log of 5. And very often when you're condensing, you'll see it written like this, log of 5 over 2. And so they'll say, hey, rewrite this condensing it. And you'll have to recognize that that 2 just means a 1/2 in front, which means that's the exponent, which means it's a radical. Okay? So I just want you to know that this can happen like this. And you can even see it like grouped. That's that group to the 1/2, right? Yeah, or if it was the cubed root, it would be 1/3. So you have to recognize that your radicals can be written as fractional exponents. You have to remember that property.